The human body operates as a high-speed electrical grid, where every second is defined by millions of synchronized pulses. The standard view of calcium is structural, the inert physical mineral that builds our bones and teeth. In its free form, calcium functions as the body's most precisely regulated messenger. It is the literal trigger for muscle contraction, nerve firing, and immune cell activation. Curious, engaging. This occurs through a specific active fraction known as ionic calcium. These free-floating ions carry a 2+ charge, allowing them to act as a second messenger inside virtually every cell. Whole body health relies on the precision of this reading. When the signal drifts, cells stop talking to each other properly, and the body's internal communication network begins to fail. Today, demographic pressures like population aging and sedentary lifestyles are pushing this signaling network off balance. Engineered for spaceflight, they lose up to 30% of their bone strength during 6-month missions. Without gravitational loading, their cells lose the ability to sense the signal. Their bodies have the raw material, but the bone remodeling cycle becomes uncoupled, proving that bone loss is a signaling failure rather than a nutritional shortage. This is why standard calcium supplements often fail. They are typically absorbed in a protein-bound form that the body's sensors cannot read, effectively remaining invisible to the cells that need them most. This unreadable calcium can worsen the problem by enlarging the pool of inactive calcium in the blood, which eventually precipitates as plaque in vascular walls and deposits in the joints. When this cellular communication network breaks, the consequences reach far beyond the skeleton. A degraded calcium signal is the upstream feature shared by over 150 chronic conditions, from osteoporosis to cardiovascular and neurodegenerative diseases. Calcium balance is a constant conversation between 5 specific tissues: the parathyroid, the thyroid, the kidneys, the intestines, and the bones. They communicate through the calcium sensing receptor, or CASC. This sensor sits on the surface of cells in each of these tissues, reading the ionic calcium concentration in the surrounding fluid. This diagram represents that continuous loop. In a healthy state, ionic calcium is sensed accurately, and the 5-tissue conversation remains quiet and perfectly balanced. But when the signal is lost and the receptors are starved, the breakdown manifests at the molecular level within the cell. Calcium leaks into the cell faster than it can be cleared, leaving the mitochondria flooded by a sustained overload. This overload causes the mitochondria to produce reactive oxygen species. This molecular damage drives both the aging of the bone and the progression of systemic illness. Anti-orbital ionic calcium, or AIC, is a biochemical intervention designed to deliver calcium in a free, ionic form the receptor can actually read. Regular calcium carbonate uses strong ionic bonding that holds the calcium tightly, leaving the molecule with no net charge. In AIC, a weak anti-bonding interaction allows the calcium to maintain its 2+ charge and its electrical polarity once it enters the bloodstream. Because the body's sensor is highly sensitive, AIC only needs to increase ionic calcium by a margin of 1 to 2% to re-engage the CASR and restore the signal. This triggers an immediate corrective response. The parathyroid quiets its hormone output, and the thyroid C cells regain their ability to restrain excess bone-removing cells. This sustained availability of ionic calcium also allows the receptor to partner with the BMP2 protein. This specific interaction commands stem cells to differentiate into osteoblasts, which begin laying down brand new bone. Unlike traditional drugs that only slow down bone loss, AIC provides the sustained signal necessary to recouple the bone remodeling process and switch new formation back on. Because every tissue relies on this calcium choreography, restoring the central signal creates benefits that extend far beyond the skeleton. In the heart and blood vessels, restoring ionic signaling allows cardiomyocytes to regain their precise rhythm and encourages the gradual clearing of ectopic calcium from the vessel walls. The immune system responds as well. By restoring the proper set point, immune cells can activate and stand down correctly, providing a balanced response rather than broad suppression. As the intracellular signal is normalized, communication pathways are cleared across the entire nervous system and physical network. Cellular health is not maintained by the total amount of calcium in the body, but by the precision with which that calcium is moved. Healing begins by restoring the electrical signal the body uses to repair itself.